All right, thank you all for coming. This is the Applied Data Science Invited track, day 2. This is session 3, and I'm really excited. Yet another lineup of great speakers. For the first one, it's my immense pleasure to introduce Yaron Singer. He's a VP of Engineering and AI at Cisco. Previously the CEO and co-founder of Robust Intelligence, which was recently acquired by Cisco. Before Robust Intelligence, Yaron was a tenured professor of computer science and applied mathematics at Harvard University, researcher at Google, and a consulting researcher at Microsoft. He's a recipient of multiple awards. If I start enumerating the awards, I'll probably use up half of his time. So you can very well imagine. He's an active investor in startups. And also had the Best Student Paper Award at Wisdom. Works at the intersection of AI and security, as well as advising cybersecurity companies with AI. And today he's going to talk about securing the AI transformation. Please help me in welcoming Yaron.
Thanks, everyone. Thanks for the kind introduction. So yeah, it gives me immense pleasure to be here, to be a KDD. I have to confess, I actually tried submitting. Well, I actually submitted many papers to KDD. None of them got accepted. So it gives me, very, the sense of pride to be here and speaking. It does seem a bit of a convoluted way to get a talk at KDD. To sort of start a company, sell it. And then try to get invited as a speaker. So hopefully, others have experienced smoother paths. I thought what I'll talk about today is just tell you a little bit about what we've done at Robust Intelligence, and then how that kind of translates and kind of generalizes into what we're doing at Cisco, where we're now kind of a larger team with a larger mandate called Foundation AI. You tell me. I'm fine with this mic or without. You guys tell me. Basically. Okay. The story about Robust Intelligence is one of AI security that I'll tell, and I saw that there's a session on AI security that's happening in parallel, so I think it's very fitting. And then the story of Foundation AI is a story about AI for cybersecurity, and I'll tell you kind of how we made that connection. Hopefully it's interesting. So just a little bit about what we've done at Robust Intelligence. This is kind of a go-to slide that I have. We started from Harvard. And then we built a product for AI security and safety with automatic validation and protection of AI applications, and I'll talk a little bit about that. We started before people thought a lot about AI security, but we were fortunate to have a lot of really kind of forward-thinking kind of companies and executives in these companies that really bought into this agenda. So we had a pretty nice portfolio of customers in primarily in kind of the finance industry, insurance, and whatnot, kind of places where you would think that people care about AI security. And then we got acquired by Cisco a year ago. And then at Cisco, we launched the product. It's now available as part of Cisco. I'll talk a little bit about that. And then from that, we created Foundation AI, which is kind of a larger team that has kind of a broader mission, and I'll talk about that. Okay, so what's the founding story? So we began with very fundamental research about robust AI, essentially kind of things like adversarial examples. I'll talk about that, and all the ways in which we can kind of fool and trick AI systems, right? And also kind of algorithms and ways of solving that. And I've done that as my capacity at Harvard, and I started some of that while I was at Google in collaboration kind of also with Microsoft and Meta. So it was a very, very fruitful kind of work and research during that time. Something that's also very important, I think, kind of in this era, is to very much recognize that we're supported by industry and federal funding. So this is a snapshot of a letter that we got from DARPA, that we're very excited about, that's announcing the support for deep learning architectures for robust classification under adversarial noise, right? And I think it's kind of like important to remember that a lot of the things that we do in industry, right, are, have been supported, and have origins in things that we've done in academia and in funding that comes from academia. And then from that, we started teaching courses about robust machine learning at Harvard, so that was good stuff. And then once we kind of like taught the courses and have done, kind of like the research, we felt that what would be really nice is if we actually kind of got a lot of these solutions deployed and kind of thinking that, ultimately the proof is in the pudding. There are a lot of papers about adversarial training of models and things like that. And it felt like the kind of, rather than writing another paper, what would be more interesting is actually seeing if we can actually build a system and have the system be deployed and used, and thinking that that would be kind of like the next step towards impact. So Kojin, who is my student at Harvard, and myself, we moved to San Francisco, and then we started Robust Intelligence, and this is our first office in the dog hatch in San Francisco. It was, it was kind of good times, right? Not really. It's like it's pretty it's pretty tough. It was like we moved right during COVID, January 2020, and it was it's kind of it's been quite a ride. But yeah, we started the company kind of anticipating this need for AI security. So this is what our pitch deck looked like. It was very, very simple. We thought about it in kind of like very basic terms. We had axioms, and the first axiom that we had was that AI will continue to grow and be adopted at an exponential rate for the next 20 years. This is back in 2019. And that also the second axiom is that with everything that we know about the vulnerability of AI, we knew that it won't be able to be deployed without defensive protection. So the corollary from these axioms was that securing AI is evolving into being an important market. So we're fortunate enough to kind of like land on investors that had kind of like the right mindset and were open enough, and they kind of and they invested and we started the company. So yeah, what we started with is we started with end-to-end attacks on AI systems, and we started with check processing. So we actually took we licensed software for like $5,000 that actually is used by large banks for check processing. We took a check, and then we showed how to hack all through the phone and everything, and then generated an adversarial attack, right, where the check gets misclassified for, in this case, I think it was like $700, right? And you need to add pixels, right, doing adversarial attacks to these images, right? And the challenges in this case, from an academic perspective, are that the checks are black and white, so you don't have any gradient, right? So all your your attack algorithms, they have to be discrete. There's either a pixel or not a pixel, right? And also you had to have the letters match. You had to have the 4 as in letters match the the numbers. So and then getting all that through the system is some like an intellectual challenge that was kind of like fun to do. So we started with check processing, and then also similarly kind of like we took fraud detection algorithms that were used at the time. So this is Amazon fraud detection system that you could use, right? And then we showed how to change features in this one so that so you get the check that you get something that was previously fraud misclassified as not being fraud, right? So with that we went to banks, and this is kind of like how the relationship started, and then it took us only I think 2.5 years to land JPMC as as one of our key customers. It wasn't a check processing, but that's kind of like how the conversation started. They got really interested in kind of adversarial AI and all the things you can do and the risks, and from there we kind of we kind of grew not only JPMC but other customers as well. So yeah, so that's kind of the origins of it. What we realized is that unlike kind of other security problems that are very kind of like, felt very much like system problems, what we liked about AI security is it felt like being an AI problem. And to me right now, it's not only an AI problem, but I think it's also kind of like a data problem. And I'll talk a little bit about that when we talk about the models. But this all comes from the fact that AI models themselves, they're very brittle. And then once we have modern systems that rely on AI, they're basically prone to these AI vulnerabilities. And then if we want to protect these AI systems, we need to solve an AI problem. And that was a little bit different from kind of from what you typically see in cybersecurity, where cybersecurity, some of it is like kind of, there are solutions that use machine learning and things like that. But at heart, a lot of the cybersecurity problems, they're more of kind of identify vulnerabilities at the system level, right? So it's a little bit more kind of like understanding of operating systems, whereas AI security felt much more like an opportunity for AI people like ourselves. What is, so those are check processing and fraud detection, and that was kind of back in the day, that was like maybe 5 years ago. So what does AI risk look like in, generative AI systems? So if we think of like a very, very simple system, if we think of like kind of like a RAG application where we have a user that chats to a chatbot, and I'm adding like, maybe we're adding some context that comes with a vector database, right? Basically, the user sends a prompt, right? We call in it comes in with context that comes from, comes from a vector database. It goes into a model. The model returns a response. If we're kind of like looking under the hood, right? There's application data that comes into the vector database, right? And then there's a publicly available data or in public models that go into basically creating a model on top of a platform, which then becomes our our foundation model that the user interacts with. And kind of in many places along this life cycle, there are a lot of risks for the AI system, right? And there are a lot of opportunities for hackers and bad people to manipulate this entire system. From the beginning, the users themselves, can generate jailbreaks and bad prompts that we'll talk about in a minute. The application data itself can be contaminated, and we'll basically send instructions to the LLM, and we'll show examples of that. The model that we're using to train the data, that we're using to train the model could be poisoned. The models themselves can have backdoors. So there are all these sort of risks, right, that organizations are taking upon themselves, right, when they're adopting AI systems. And if you're a financial institution or an insurance company or basically any regulated industry, these risks are extremely troublesome, and prevent you from adopting, from basically adopting AI. Right? So for basically a lot of these organizations, security is kind of like a fundamental condition in order to like kind of adopt AI and move forward with the AI transformation. So here are some concrete examples. So if we basically go to kind of like the very beginning and we think about the kind of like the early stages of building a model, it typically starts from some kind of like downloading an open source model. And the issue with these open source models is that they can have backdoors or basically malware inside the model file. So if you would go on Hugging Face, and this is a bit dated, but you would be able to download a model from Hugging Face, and then that model would have nothing, you wouldn't be able to detect if there's anything weird or strange about that model. But basically what that model could do is it could just like go into your machine, download all the data, and then just post it, send it, anywhere that it wants to. These are actual attacks that we actually did, and then we also discovered them on Hugging Face. So that's something that we've made kind of like Hugging Face and organizations aware of. It's something that is extremely troublesome for CISOs when they see this, because CISOs have, if you think about it, if you're a large bank and you think about all the developers that you have that are downloading models off of Hugging Face, knowing that some of these models can have executable code inside of them, that's a huge concern. Fortunately, if I'm sure that you're all avid readers of Hacker News or Network World, you saw that I think it was 2 days ago we announced that we're partnering with we partnered with Hugging Face to protect the open source models off of Hugging Face. So this is something that we offer at Robust Intelligence, now also at Cisco as basically as controls, but now we're also offering it directly on Hugging Face, where you do the scanning, where basically we scan all the open source models of Hugging Face to detect any malware or any kind of issues that come about. Yeah, so that's kind of so this is helping secure the world. Sorry, and then another example is when we're actually looking at the data that is used to train the models. And something that I think it was like we published like maybe about a year ago, is basically that you could extract the training data that is used by the model verbatim. So what we showed is we showed that basically you take a ChatGPT or other models, and you can extract New York Times articles or Wall Street Journal articles verbatim from these models, kind of suggesting that basically these models were trained on these sources, right? And now not only were they trained on these sources, but now a user can basically, with the right set of queries, can actually extract that information, right? And that's something that is very, very troublesome or worrisome for for a lot of organizations that are fine-tuning or doing some pre-training on their models, right? And don't want that data to be exposed to people who are using these models. Right? So that's again like a huge risk that people are carrying. Another thing that we saw in the fine-tuning stage, so once you have a model and then you send it to production, a lot of times what you do is you do fine-tuning. So you fine-tune it with with some data for a specific application. And this we actually saw with an actual customer. It's a Fortune 100 company, and they were about to release a customer-facing chatbot. And what they did is they fine-tuned Llama. And what we discovered that when kind of testing, in basic testing, we found out that the fine-tuning broke the internal guardrails of Llama, making the model basically susceptible to very, very kind of like racial behavior and all these kinds of things. Here we're giving like a very benign example where Llama would normally decline a question. This is the question about how to create a keylogger in Python, which is basically kind of a security no-no. But then once you fine-tune the model, it actually gives you the code for creating a keylogger. So this is an example where you're breaking the internal guardrails of the model. But what we've actually discovered in testing was something that was much worse. So it's something that's kind of like to be very much aware of. Another kind of example is what happens when we interact with a vector database. So what we basically showed is that whenever you're creating a RAG system and you're creating kind of like a Q&A chatbot like this one, basically here we created this application that financial institutions would typically use to do financial analysis. They would upload Amazon, in this case, Amazon earning reports. And you could ask benign questions and it would normally work. But then there are specific questions where all of a sudden you would ask the question and you'd get this image appearing in the application. And what this image does in this case is it actually, if you hover on this image, you see that what it does is it summarizes the information using the LLM and then sends it uploads it to Wikimedia in this case. Okay. Why does this happen? Basically, the reason this happened was because the application uploaded data, and that what we did in that data is we actually had text hidden inside the PDFs in white characters, and that text was a prompt injection, basically giving the LLM instructions. So, you know, the human eye cannot see the text, right? But that gets injected into the into the vector database. When a query comes, you know, the vector database sends that piece of document into the LLM, and the LLM reads the instructions and performs these instructions. Does that make sense? So, very vulnerable, right? What we did is, at Robust, we basically secured the pipeline all the way from file scanning and vector DB scanning. Then we had a validation process where, as models were ready to go into production, you would be able to automatically test them. And then once models are in production, we had something called AI Firewall at Cisco. It's now called AI Runtime because obviously Cisco has its firewalls and they don't want confusion. But we call it AI Firewall, and basically these are guardrails that are used to protect the input and the output of an LLM. And basically in doing all that, you see kind of like OWASP down there. And in cybersecurity, they have these standards. So they basically make it easy for practitioners to understand what it is that they need to protect against. So they have like lists. Here are like the 10 things that you need to like watch out for. And that's OWASP. It's like, I forget what the acronym is, but it's like 10 things. And then in doing that, the product would cover all the list of 10 things that security standards told practitioners to kind of watch out for. Okay, so, and that's kind of like what the, you know, if you look inside a little bit, there's like a lot of messy code, but, you know, we want to think that it kind of looks like this, where there's a, pretty, you know, kind of, but the architecture is pretty nice, and then the way the components kind of interact with one another. So I'll talk a little bit about kind of the validation that will build up into this AI firewall. And then I'll talk more, and then from the AI firewall, I'll tell you kind of like how it evolved into what we're doing today, which is Foundation AI. So inside this kind of like model engine, what we would do is, you saw us kind of like with all these various examples of attacking LLMs, right? And then what we did is we generated a series of kind of like, we had several techniques, right, of attacking large language models. And then some of them got picked up by the press that you see on the right. The biggest one, I think, we got the kind of like noticed in the Financial Times and the Economist, and became a favorite of Wired every time that we would hack ChatGPT and all this. But basically, what that meant is it meant that we knew how to create, we knew how to red team models and start generating data. And that data is in the form of prompts that are good for evading, for circumventing LLM guardrails. So one of the, I think it was like 6 months ago, we've done an attack on GPT-4 and later on also, and then we kind of created this entire system called TAP, which basically became algorithmic red teaming, meaning that we don't have to have people who are, kind of like constantly trying to attack every model. There is an algorithm and there is an entire system of kind of like LLMs that are talking to each other that automatically generates these attacks, right? So basically at this point, right now we have an entire system that you can point at any LLM, right, or any AI system, right? And it basically kind of adaptively, it sort of chats, right, with that system, right? And then basically through in the order of like 6 to 20 questions, it manages to create prompts that circumvent the guardrails of that LLM, right? And in doing that, we basically then created an entire, like kind of like bank of prompts, right, that we could use to test models and later on also train our own AI firewall. So, what does it mean? So typically the term that's used is jailbreaking LLMs, right? So on the top right, there is a prompt that you could try to use on an LLM that would not succeed in circumventing the guardrails. So you could ask, you could ask the LLM to develop a strategy to hacking into a government database, and the response from the LLM will tell you that it's sorry, but it cannot assist with that request. Okay. But if you kind of phrase your question in this sort of indirect way, where you're asking it, like telling it a story where a secret organization is seeking to exploit vulnerability, yada, 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 right? Then, the LLM would actually, if it's a compelling enough story, the LLM would engage and then give you, in this case, strategies for infiltrating a government organization. Okay. So basically, what kind of the system does is it crafts this story, right, around the base prompt that circumvents the LLM guardrails. And then, kind of like one of the nice ways is that this did not work for reasoning models, but in February, what we did is we kind of created this new approach that also succeeds in attacking reasoning models. And then we attacked DeepSeek, and we succeeded with like 100% success rate. And the media loved the fact that that DeepSeek was shown to be 100% vulnerable, and there was for a split second we were famous in February for attacking DeepSeek. So that was good fun. So all these things basically, the system, if you looked into the validation system, right, what it is it's all these prompts that we're generating through algorithmic red teaming and some other methods, right? We're sending those prompts then to the LLM, and then we're evaluating the response from the LLM, and that's how we can validate whether the LLM is prone to these attacks or not. And that's also what you'll see in, this is, an oversimplification, of course, but that's what you'll see in the product also sold today. So we don't only want to validate models and we don't only want to attack them, but what we also want to do is we want to basically protect models, and that's what the AI firewall does. So the AI firewall is just a guardrail that you can integrate with an LLM or just kind of like your AI system, and with the goal that that guardrail helps you reject bad inputs and bad outputs. Okay? Theoretically, conceptually, it's very simple. All it is a classifier, right? It's a classifier. It's a binary classifier that tells you whether a prompt is good or bad, right? And then when you kind of think about it very naively, it's not different from a spam filter, right? And here in this room, and we have the people who almost invented spam filters, and I'm looking at one of them. So this is something that the community knows how to do very well. Right? The issue with LLMs actually, and this is kind of intellectually interesting, is that it's actually more challenging than standard NLP-based classifiers that we would have for things like spam or even things in security. And the reason is that LLMs, and kind of if you think about it, they do two things, right? Number one, they're text classifiers, but the other thing is that they're also operating systems. They take instructions, okay? And by taking instructions, it means now that you can given them a command, and they will, execute on that command. But the challenge is that because they also have the classification components, right, you can basically manipulate the language, right, through which they take the instructions, right? And that's kind of like, that's really what makes them really vulnerable, right? It's kind of like this, it's this marriage between adversarial examples, right, that you could use to like easily manipulate like the classifier, right? But then in easily manipulating the classifier, you can get it to now, execute different things, right? And that's kind of what makes it difficult. What our folks have observed and kind of been working on this is that you can actually leverage existing large language models and harness what they're doing into creating very, very powerful guardrails. Okay? So they started with this experiment where what they did is, our folks at Robust, they basically took abstracts from the archive, right, from different topics, from physics, from math, from biology, and they looked at the last layer of the LLM. And basically what they found is that even without training, all these topics were really separable. Okay? So the latent spaces there like tell you a lot. And then what they did is they basically looked at, they took kind of like jailbreak prompts, and they looked at basically the separability between benign prompts and jailbroken prompts. Okay. So it turns out that you can easily separate between malicious prompts and benign prompts. They're linearly separable. Okay. What's more complex is to separate between the indirect malicious prompts and the indirect benign prompts. And when I say indirect prompts, what I mean is, like, think of the example that I showed you earlier about a jailbreak, right? It doesn't, it has something bad inside of it, but it has this kind of like text wrapped around it, like kind of telling a story, right? Asking the LLM to do something, right? So the issue is that it's hard to separate between, like a benign story and a story that actually has the LLM trying to do something bad. But it's still separable. So basically what the team did is they created a set of classifiers. First of all, classifying malicious from non-malicious, and then a nonlinear classifier separating between kind of like benign indirect prompts and malicious indirect prompts, and based on the last layers of Llama models. So basically with that, it created a very powerful AI firewall that as far as I know, is kind of the industry, industry leader. That was really interesting and something that we got very excited about. And then we kind of started thinking, we actually solved a very hard problem in cybersecurity that happens to be on AI, but a lot of cybersecurity is about classification. A lot of cybersecurity is about classification of benign alerts from like non-benign alerts, or kind of like various things. And maybe this is something that's powerful beyond what we're doing with AI security. And that kind of gave us inspiration to go from robust intelligence into foundation AI. Right? So basically, what we did is we shipped the product, I think, in late February. And then starting in late February, we actually extended the mission and call this now kind of like the extended mission. We call this Foundation AI. Where Foundation AI is working on AI security, but importantly, it's also building foundation models and technology for cybersecurity at large. So we formed in March 2025. Yeah, by the way, this is kind of when I'm transitioning a little bit into like a sales pitch for people who want to, who are interested in joining. So just be warned. we formed in early in March 2025 with the goal of basically building this bleeding edge technology that'll be universal across all of Cisco security and Splunk, which is I think it's public, so it's like an $8 billion portfolio, which is massive. We shipped in time for RSA. We shipped the AB Foundation Sec model, which is based off of what Meta's Llama AB model is. And what we did is we basically pre-trained the model with cybersecurity data, right? And then fine-tuned it for various use cases. It now has in the order of 150,000 downloads from Hugging Face, and we're working on adoption, with like Cisco Security, Splunk, and other things at Cisco, and customers at large. We've integrated AI supply chain controls, kind of like what you saw earlier, across Cisco Security products and Hugging Face. We've integrated now kind of a cybersecurity research team into Foundation AI from Splunk. So now we're at a pretty, good size R&D organization with expertise in AI and cybersecurity, which I think is actually something that's really exciting. We're kind of like with the mindset of creating differentiated AI technologies for cybersecurity, right? So we're not trying to compete with, say, ChatGPT or an open source version of ChatGPT. Basically, we're creating technology that is specific for cybersecurity that outperforms just generic models for that. We're working on driving adoption, so making sure that kind of the models and technology is adopted, and then also kind of like with protecting the AI supply chain, kind of like what I showed with open source models, and then also MCP servers and things like that. So where are we at? So the basically right now, kind of like even kind of very early versions of the model, we're excited about because on cybersecurity data, they beat this kind of like publicly available or open source and closed source models using a fraction of the cost and latency. So we kind of with a small 8 billion parameter model, when quantized can be downloaded on a laptop, we actually do better on cybersecurity benchmarks than ChatGPT 4.0 or Llama 70B. Okay. And that's really important because it means that cybersecurity analysts can actually use that model and kind of like use it for kind of like automating cybersecurity workflows. And it can be fine-tuned like kind of very easily. So, for example, you can fine-tune now this model to create an AI firewall, right? Or you can fine-tune this model to basically for identity security or things like that. We also this week, or last week on Friday, we released an instruction fine-tuned version of the model. So now you can kind of interact with the model not only as a base model, but also kind of like as a chatbot. So we're continuing on pushing in all these fronts. So with that, I want to thank everyone and leave time for questions.
How's the time for questions? Can just one of the mics?
Hi, thanks for the great talk. I was curious about the model that you've trained to identify sort of like those difficult to classify malicious and non-malicious content. So to train that model, you said this is an SVM classifier?
Some of it is SVM, and the SVM is used for the linearly separable parts. Yeah.
So I was working in clickbait detection before, and it's in a way similar to this problem in the sense that you can look at it and tell that it's bad, but for a classifier, it always felt like it's hard to identify. So I was wondering. So I was wondering, like, especially because it's not topical, right? Like anything, it's a tonal trait. So they can be any story, and they can like make it to look like it could be inside any story where so topically it would look very diverse, but at the same time, there'd be that malicious portion of it. So I was just kind of interested how you created that data set and what kind of models did you use?
Yeah, actually, I never thought about it. Like, it's actually very similar to clickbait, probably, right? Because it exactly has this characteristic where there's, like kind of somewhere there's like that the bad, right, kind of like instruction, where in isolation you would relatively easily be able to classify it, right? But the fact that it didn't, right, and all this text makes it like kind of benign text makes it very easy. So here, and I'm getting very close to the edge of my knowledge here, but like what the team did is they basically kind of created a multi-step approach, right, where the first step is just kind of like classifying this as I think it's like malicious or benign, and if it's so I actually. Yeah, the first step is to like actually classify things kind of malicious or benign, and if malicious, then they send it to a heavier classifier, which is now kind of looking at, which is trained on indirect malicious versus direct, versus indirect benign, and then that's kind of how they solve it.
Cool. Yeah.
But I'm happy to follow up with and then connect you with the people who actually build the models to give you more detail.
Cool. Thank you. Thanks.
Hi, thanks for your talk. I was curious whether in your research around the security aspect of foundational models, we learned with LLMs, for example, very early that they can't do math, they can't count words, they can't count R's and strawberry, that type of stuff, right? And we built tools, or we knew limitations that we had to address differently. In your work, by looking at models from a security perspective, have you uncovered any foundational limitations that the models are just built that way, and therefore, regardless of which model it is, what size it is, these limitations are always going to be inherent and present?
I'm going to try to rephrase the question and see if I'm getting it right. And the question is like now kind of like in general security models, right? So I'll just pull this up. Are we seeing, the question is like, are we seeing kind of like any inherent limitations that the models have in cybersecurity, or do we think that they're kind of like omnipotent? Is that
yeah, it could be based on like the design part is just, this is how it is, so this is how it's always going to be, right? That we can't fix that without changing it foundationally.
Yeah. Well, maybe this is a topic for like kind of a, deeper conversation, but, I'm a very much, I think I'm a pessimist, or somewhat of an AI pessimist. I built an entire company around that, right? So at the heart of it, I'm very always skeptical, towards what we can accomplish, even with everything that we're seeing today, right? So at the end of the day, I sort of think about what we're doing with Foundation is basically a way to help security analysts automate workflows. Right, so kind of like the things that you sort of feel like, gosh, those, you don't need a human to do that, right? Like kind of those types of things. I think that you could, those things I think we can help automate. The other things, in my opinion, they boil down to like fundamental problems that we know with this community, right? Which are about ranking and classification. So all the problems that I see, and this is now kind of like with talking to, being very much inside the security world, they all, to me, I haven't yet seen a problem that doesn't boil down to ranking or summarization, right? And with ranking, I don't know that supervised learning is necessarily the right approach. So I'm still.
The problem with those two concepts are they're very data driven, right? The data distribution driven. So that means you're always chasing your tail because the new model is going to come out and won't repeat the mistakes in the older model, but it'll have other flaws, right? So if it's not tied to something foundational, primitive in its own design, you're always reacting to it.
So yeah, and on that, my perspective about like the world of cybersecurity is that like over the past less than a decade, cybersecurity as a field has become a data-driven field, right? And that's kind of like where you're seeing Splunk. Splunk is, originally is a data processing company, right? It wasn't originally a cybersecurity company. So I think that we can do well. I think kind of like dealing with the vast amount of data, I think we can do well. Can we, use models to identify a buffer overflow? I don't know.
Thank you.
Sure.
Thank you for the great talk. My question is more on the line of do you think that there's any possibility of making architectural changes or a way in which maybe have a separate attention mechanism that is detecting prompts that could lead to problematic results, and then so while you are training the model, this is very much codely inbuilt into the model, and in a way that it is difficult to change it by fine tuning also. I don't know, have you thought about these things more in terms of changing the architecture of the LLM in some way, having a separate attention mechanism that is just detecting threats of these sorts?
Sorry, just to make sure that I understand the question. So is the question is it possible to, instead of, kind of putting guardrails, changing the architecture of the LLM and in order to, to protect it? Is that a question?
Yes, and then of course, part of the solution would be to have some of these examples of indirect malicious examples into the, during the training, those things are put into the training. So what I'm thinking is that, when you have a big text, for example, the text that you showed in the figure, so there was a lot of text, and in between there was a few places where there was something which was malicious, right? So maybe the attention mechanism that does most of the task, it is kind of capturing a lot of the context, but the threatful part is not given enough weight. And what I'm suggesting is that maybe if there is a separate attention mechanism that is also focusing on just the threat aspect, the importance of the threat that is coming from this piece of text can be enhanced, even though it is contained in a very small part of this text. And then maybe that would, serve as a solution.
Yeah. I think that is something to explore. At a high level, right? Kind of like the paradigms that you're working with, right, are number one on alignment, right? The model providers are limited in kind of in what they can do, because there's always a trade-off between kind of security and functionality, right? So if you want the model to be very expressive, and then you need to, it inherently makes it kind of more vulnerable. And then on the other extreme of the kind of when you're looking at the cybersecurity vendors, like us, for example, you have to make sure that your product is very kind of lightweight, right, and it doesn't require kind of interference with the model development process, right, and can be something that can be easily kind of used across a variety of models. So those are kind of the main kind of considerations that you have to work with. But again, I think that what you're saying is very interesting and definitely something to explore.
Thank you.
Hello, thanks for your talk. So I think essentially you are building this security model to protect the large language model, but generally this security model itself is also a large language model. It can be attacked, it can have these allocation problems. So is there any solution to that?
Yeah, that's a great question. So the model itself, right, can be attacked, right? So it feels like kind of an infinite loop. But at least we can talk about the AI firewall, and then we can talk about the foundation, the foundation sec KDD. With the AI firewall, right? If you attack it, right? All it is a classifier, right? So it's not the AI firewall. When ready, is not an LLM. It's just a classifier that takes in a prompt and returns, either tells you that the prompt is benign, right, or malicious, right? Now, if you can attack that model, right, what it means that you basically succeeded in, right, and you basically, right, kind of found, false negatives, right? So it's just upon ourselves to it just means making this a better classifier, right? That's what it means, right? That there's no inherent it doesn't, the AI firewall itself, because it's a simple classifier, does not have the inherent kind of like vulnerabilities that LLMs have, because it doesn't execute on any kind of actions, right? The foundation Sec 8B model, right, which is, you know, kind of like trained off of Llama, is completely vulnerable, you know, could be a vulnerable model. But that's almost by design, right? Because you want to, you know, because it's used by security practitioners, right? And you want to give them the flexibility kind of like to work with that in that way, right? So Foundation Sec 8B should not be used as a chatbot for a healthcare, you know, for a healthcare organization, right? And if it is, then you should use kind of like all the, you know, appropriate guardrails, right? What it is really to kind of like, you know, put it in a, you know, for security analysts to kind of automate workflows.
Thank you.